All right, students and parents, this video is a how-to video on how to subtract up to 4-digit numbers. In Virginia, this is a 3rd grade standard. I'm going to show you 3 strategies today how you could subtract numbers up to 4 digits. So the first strategy I'm going to show you guys is adding up. The second strategy I'm going to show you guys is using place value and thinking about negative numbers. And the third strategy I'm going to show you guys is that traditional, and I'll also show you the expanded algorithm with regrouping. And parents, students do not have to master all of these strategies, but the reason why we teach flexible strategies in school is so that each student can use a strategy that makes sense to them instead of trying to force them to use strategies that make sense to us. And all of these strategies are based off of how students naturally learn how to do computation. So let's just start with adding up. Here is a sample problem. It's a 4-digit minus 4-digit problem for subtraction. And if you set this up and you stacked it, the first things students might notice is that this problem is going to require regrouping. Now, regrouping is hard for many students, and the reason why it's hard is because you have to really understand what's going on with those shifts, and we're going to be talking about that when we do that strategy. But that doesn't mean that students have to regroup. So I will show you the first strategy is adding up. And you can actually use addition for subtraction. The reason why you can use addition for subtraction, I'll just back up a little bit to explain that. Let's talk about what we know about addition and subtraction, because these are related operations. So addition is when you know both parts, and what you don't know is the whole. You're putting those parts together. So part plus part would give you a whole, and I don't know the whole. Now, subtraction is related to addition. With subtraction, I know the whole and I know one of the parts, but I do not know the other part. So you can think of subtraction as takeaway, like whole minus the part that I know will leave me with the part that I don't know, or the difference between the whole and the part. But many students like to think about subtraction by using what they know about addition. So fact families and related facts can help me with this. I can also think about solving a subtraction problem by starting with the part that I know and adding on until I get up to the whole that I know. And then when I'm adding on, this is also the other part. So if I think about what I'm starting with, the part that I know, and I add up to get to the whole, that other part would be the difference. So let me show you how this would look with some smaller numbers, just so we can connect this up to larger numbers. So for example, if I had a whole of 5 or a set of 5, and let's say part of the set, 3 of them were colored in, part of the set is colored in and part of the set is not. So if I wanted to figure out that missing part, I could either think 5 and take away the part that I know, which is 3. That would leave me with 2 that are not colored. But I could also think 3 are colored plus some more gets me up to 5. So 3, 4, 5. And again, here's 2. So as you can see, I can either take away the part from the whole, or I can start with the part and add on the other part to get up to the whole. And when students are learning this, they start doing part-whole relationships in kindergarten, and they continue to practice all the way up through elementary school. But sometimes students stop using part-whole relationships as the numbers get bigger and they stick to the traditional algorithm, but they may not be doing it with understanding. So it's very important to expose them to multiple strategies so they keep building up that number sense. So now that we understand why we can start with the part and add on the other part to get up to the whole, let's see how that would look with larger numbers. Just because students can do it with smaller numbers does not necessarily mean that they connect it up to larger numbers without being taught or practicing it. All right, so let's take a look at this problem. 2,103 minus 1,675 would give me the difference here. So first thing you need to think about is when I'm subtracting, I'm starting with the whole and I'm taking away a part. That would leave me with the other part, and in this case, I don't know the other part. So if I were to draw a model of this, a part-whole model, I know that 2,103 is the whole, and that 1,675 is the part that I know, and what I don't know is the other part that it would take me to get up to that whole. But I can start by using an open number line. If I'm starting with the part that I know, that would be 1,675. I can add up in chunks to get to my whole. And my whole is 2,103. Now, when I'm making these jumps, it's very important that I don't forget about place value and number sense, because if I just want to jump up by ones, it's going to take me a very long time. So what I try to help students understand is that if they use what they know about place value to make these smart jumps, then the part that I jump up, which would be the part on the line, will be very easy to tell what it is if we're thinking about place value. So first things first, if I'm starting with this part, my first job is going to be to get to the next 10, okay? So if I'm looking at the number 1,675 and I want to get to the next 10, I need to be thinking what is 10 more than 70. Since right now I have 7 tens, or there's a 7 in the tens place, then I know this is 70 as my 10, and 10 more would be 80. So the next 10 would be 1,680. And you see you have 80 there, that's a multiple of 10. So this is my next 10. Once I get to my next 10, my next job is to think about what would be the next 100. So if I look here in the hundreds place, I have 600s. If I add 100 onto 600, I will have 700. So my next 100 would be 1,700. See, that's 100. That's a number that I say when I count by hundreds, right? So this is the next 100. After I get to the next 100, I want to get up to the next highest place value. And after the hundreds place comes the thousands place. So I have 1,000. I know I need to get up to 2,000 in my whole. So my next 1,000 after 1,000, if I add another 1,000, would be 2,000. And 2,000 is my next 1,000. Once I get to my next 1,000, I can take a jump or I can take multiple jumps to get up to my whole. Okay, now let's think about what's going to be in each of these jumps, because even though they look about the same length, they're not going to be the same amount. Just for space purposes, I can't really stretch out my number line much more. So if I'm at 1,675 and I need to get to 1,680, I know both of these numbers have 1,000 and 600s. If I'm thinking I have 75, I can think 75 plus how much more gets me up to 80. And since I know that 5 plus 5 gets me to 10, then I know that 75 plus 5 more would get me up to the next 10, which is 80. Or I can count on 75, 76, 77, 78, 79, 80. So I know that to go from here to here, I am adding 5. All right, so now that I am at my next 10, I need to work to get up to the next 100. So I'm at 1,680, and I need to get to 1,700. So I'm at 680, and I need to add on to get up to 700. Now I could add on by ones, but that's going to take a long time. And since 80 is a 10, why don't I just add tens? So 80 plus another 10 would be 90, plus another 10, 690 plus another 10 would get me up to 700. So if I'm adding 2 tens, that's the same as adding 20. So this here is a jump of 20. So far, so good. so now that I got to 1,700, which is my next 100, I need to get to my next 1,000. So I'm at 1,700. And I need to get up to 2,000. Oops. Plus something gets me up to 2,000, right? So some students like to stretch this out to help them think about it. So 1,700 is 1,000 plus 700 plus some other number would get me up to 2,000. I know I have 1,000 already. I need two 1,000s. So 700 plus how much more gets me that second 1,000. If I know 7 plus 3 is 10, then I know 70 plus 30 is 100, and 700 plus 300 would get me to 1,000. So then if I have 1,700 and I add 300, then that will get me to 2,000. So this here is a jump of 300. Okay, so almost there. All right, so now I'm at 2,000 and I want to get up to 2,103 because now I'm up to my next 1,000. Now I could take this in 2 jumps or I could take it in 1 jump. I'm going to actually back it up and take it into 2 jumps for you guys. So if I need to get to 103, that would be a jump of 100 and then a jump of 3. And then that will get me up to 2,103. Now when I'm looking at my open number line, these chunks along the open number line, when I put them together, they're going to give me the other part that I need, so that I can have part plus part would get me up to the whole. And then if I know what that other part is, that's going to also be my difference. So when I'm putting these parts together, I like to put like things together first. So if I have 300 and 100, I know that that's 400. And that's together now. I don't have to worry about that anymore. And then I'm going to look for any multiples of 10. So I got 20, but I don't see any other 10s. And then I see 5 and I see 3. That's 5, 6, 7, 8. 400 plus 20 plus 8 equals 428. So that means that since 1,675 plus 428, because now I know the other part, gets me up to 2,103. Then I also know that related fact, 2,103 minus 1,675, if I took that part away, it would get me back to the other part, which would be 428, which is my difference. So that's one strategy, the adding up strategy for subtraction. The next strategy I'm going to show you, this kind of rubbed off a little bit, is how we can use place value and think about negative numbers. Now, all of the strategies that I'm going to show you today are using place value. If your students do not understand place value, then that's definitely an area that you want to be working on with them, because anytime that we are doing computation, place value is a prerequisite skill to computation with understanding. If you do not understand numbers and how they work and how the base 10 system works, then you're going to be going through these motions of computation, but you're not going to be actually understanding what's happening with the numbers, and so then you don't actually understand the math. And that happens more than you would think. So let's take a look at how we can use place value in negative numbers. And no, third graders do not need to know negative numbers in third grade. That's not part of the third grade curriculum. However, many students, when they're learning to subtract and they invent their own strategies, many of them use negative numbers as invented strategies, and many of them would like to hold on to that thinking as they move up into larger numbers, and they get very frustrated when teachers try to reprogram them. So just to give you an example of how this might look for a student, let's say in second grade they did a problem like 71 minus 24 Many second graders think about this as like 71 minus 24. And when they do this math, they think 70 minus 20, well, that's 50. And then if I do 1 minus 4, I'm actually going to be missing 3. And as teachers, we want to say you can't take away 1 minus 4, but really you can, because 1 minus 4 is negative 3. So I don't fight it when I start seeing students doing this. I just build on it and I make sure that they understand the math behind it and why it works. So now that you have 50 minus 3, if you have 50 and you take away 3, that's going to give you 47. And then the way that we learned in school was, well, they told us to carry the 10. I don't even remember what they told us, because I'm just telling you guys, like, none of it made sense to me when I was in school until I started teaching. But if I shifted 10 over, I would have 1 10 less here, and then I would have 10 more ones here. And whether I have 7 10s and 1 1, that's 71, or if I have 6 10s and 11 ones, I also have 71. So I have not changed that top number yet. I'm just changing the way that I'm grouping it. This is a big idea that a lot of students that go through and do these algorithms, they do not understand. So you want to make sure they understand that. All right, so then 11 ones minus 4 ones is going to be, let's see, 7, because 7 plus 4 is 11. And then 60 minus 20, or 6 10s minus 2 10s, is 47. And you can see either way that I do it, I get a difference of 47. So let's see how using this idea of place value and negative numbers, how this might look with larger numbers, because sometimes the trick is just, how do I model my thinking? So let me stretch out this problem a little bit. 2,103 is the same as 2,100. I'm going to put zeros because there's nothing in the tens place here, but I'm going to keep that as a placeholder, and then 3 ones, okay? And I'm going to be taking out 1,675, so that's 1,675. Another battle that teachers can fight with students when they're doing subtraction forever is, we always tell them start at the right. So you know when you have to regroup, start at the right, start at the right, start at the right. But think about this, when kids are learning to read, they don't start at the right, they start from the left. So sometimes it's easier, instead of fighting that battle, to let them go ahead and use strategies that allow them to start from whichever direction they want to. And this is one of those strategies. So let's think about this. 2,000 minus 1,000, that would leave me with 1,000. And then if I have 100, I'm not even going to put that yet. 100 minus 600, well, if I had 100, I'm going to draw that as a flat. We use these kind of blocks in school, and then we represent it like this. I can't take away 600 unless I went into the negatives. But if I did try to take away 600, I would take away 100, and then 200, 300, 400, 500, 600. I would need 1, 2, 3, 4, 5 more hundreds that I would have to take away also to be able to do 100 minus 600. So 100 minus 600 is negative 500. I would be 500 short. Okay? Now, if I have in my tens, I have 0 tens, but I need to take away 70. That's going to be a negative 70, or I'm down 70, right? And then in my ones, I have 3 minus 5. So I can do 3 minus 3 is 0, but 5 is 3 and 2 more. So I would actually be down 2. Kids that have good number sense love this strategy. They just sometimes have a hard time modeling it or keeping track on paper. All right, so now let's take a look at what we have. If I have 1,000 and I subtract 500, I'm just going to start there. That's going to give me 500. And I'm going to bring the rest of this stuff down. Now when I do 500 minus 70, that's going to be 430 minus 2. And then when I did 430 minus 2, that's going to give me 428, which is the same difference that I got over here when I was adding up. So this strategy is how we can use place value and negative numbers to find the difference. Nothing wrong with it. All right, for the third strategy, I'm going to go to that traditional algorithm that most of us learned in school, but I'm going to start by modeling a prerequisite skill that students need to have mastered before they use this traditional algorithm. Now, many math teachers will tell you don't push the traditional algorithm too quickly, because as soon as you use the traditional algorithm, students start pulling digits and they stop thinking about place value. So really, flexibility in computation is super important because it allows students to build number sense. So let's start with this riddle, just so you can see how it can look to build this place value understanding before we do the computation. So if you have a number riddle like I have 1,000, 10 hundreds, 10 tens, and 3 ones, or you give students a bag of blocks, and this set of blocks here has 1,000, 10 hundreds, 10 tens, and 3 ones, and you ask them, I wonder what number is represented here, and you let them know that this has a value of 1, then kids are going to start by grouping like blocks here. So let me just show you what kids will start doing. And you're going to want to help guide them to doing this and using place value. So they're going to put their ones together, and if this is 1, then these are tens, and then they're going to put their hundreds together. And then they'll put their thousands together. Ooh, there's another 100. And if they don't line them up in place value order, I usually just ask them, what if we line that up so that it matches place value? And then also what I ask them to do is I ask them, is there any other groups that you can make? Because when students see this, they're going to start counting how many are in each group. And then you can use a place value chart to keep track of this. So this would be 1,000 here. I'm going to write thousands for the thousands place. And if this is 1, then this would be 100. These are groups of hundreds. And if these are 1, these are groups of 10 or tens. And then these would be ones. All right, so here's my place value chart. And students, they might start writing something like this. Well, I see 1,000, or they might say 1,000, 1,000, or a value of 1,000. And then they're going to count these hundreds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there's 10 hundreds. And then they're going to think, that's weird. And then if I look here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 tens. And then 3 ones. And when you look at this number, kids are not going to know how to read that number because it doesn't match what's going on in standard form. But then you can ask them questions like, well, if I had 10 hundreds, what is the value of 10 hundreds? Let's think about that. What is 100 plus 100? Well, that's 200. Plus another 100 is 300, 400, 500, 600, 700, 800, 900, 10 hundreds. And what is 10 hundreds the same as? Well, if I stack them all up, I can see that they're the same as 1 pack of 1,000. Because every time I have 10 of something in our place value system, it can make me 1 pack of the larger place value. So 10 hundreds is the same as 1,000. So what I can do is, instead of leaving 10 in the hundreds place, I can shift these tens over with my 1,000, and now I can think of this as 2 1,000s or 2,000. Okay, now I don't have any hundreds here, but then when I look over here at my tens, I wonder if I can make any groups here. If I have 10 tens, what is that the same as? Let's see. 10 plus 10 is 20, 30, 40, 50, 60, 70, 80, 90, 100. Well, if I have 10 tens, that makes one group of 100. And you can show students by saying, well, here's the 100. And isn't that the same? 10 tens, 10 10 packs is the same as 100 pack, all base 10. So instead of 10 tens, I can group those together and think of those 10 tens as 100, because 10 tens is the same as 100. Now you can look over here, I don't have any leftover tens, and if I look at my ones, I don't have more than 10 ones. So I'm actually going to keep a digit of 0 in the tens place, because I don't have any leftover tens here, and I only have 3 ones here, so that has a value of 3. So when I do all my grouping and I put these numbers in the right place value column, I can now see that the number is 2,103, and the value of the 2 is 2,000. Since it's 2 in the thousands place, 1 in the hundreds place has a value of 100, and then I'm adding 3. So 2,103 is my number. So once you understand how to group and ungroup numbers, because what I just modeled for you guys is grouping, but students also need opportunities where they ungroup. And as I'm going through this traditional algorithm, I'll show you what that would look like, because that's part of what we're going to have to do to solve this problem. All right, here we go. So now I've set up those base 10 blocks, which I know parents, you guys might not have base 10 blocks at home, but there are virtual manipulatives out there. There's lots of great ones. I love the Glencoe virtual manipulatives. I just was having a hard time using the virtual manipulatives for a video, because I wanted to show how what I'm about to do with numbers is going to be exactly what I'm doing with these base 10 blocks. So I decided to make a video instead. So let's go to our problem. We had 2,103. That's going to be what I'm starting with. 2,103. This is going to be the traditional strategy that we're all used to from school, but I'm also going to show you a similar version where I'm just going to expand out these digits and tell the values of the digits. So 2 in the thousands place has a value of 2,000. 1 in the hundreds place has a value of 100. 0 in the tens place would have a value of 0. I just put 2 zeros because tens usually has 2 digits. And then 3 ones would have a value of 3. So 2,103 is the same as 2,103. Since I'm subtracting, I actually don't keep those addition signs in there for the expanded form. All right. So now I'm going to be taking away 1,675 was that problem I was taking away. 1,675, and I'm going to show how that expanded over here. 1,675. Now with the traditional algorithm, you do want to start in the ones place. You don't necessarily have to start with having your kids start in the ones place. As they struggle through, they realize that it makes sense to start with the ones place, so that if you have to do regrouping, you can do it one step at a time. But many students do struggle with this in the beginning. So now I'm going to start in the ones place. I'm looking at my ones, okay? I have 3 ones, and I need to take away 5 ones. Another mistake students will make often is they will use the commutative property for subtraction, which does not work, and they'll think of this as 5 minus 3. So you want to direct them up to what they have there. They have 3 ones, and they need to take away 5. I don't have enough ones there to take away 5. Now, those students that I was saying, I would just be having -2. They're going to like that negative number strategy. So you don't have to force them to use this. If they're already thinking negatives, let them use the think negatives. But for students that are saying, yeah, I don't have enough ones, your next question is going to be, well, where do I get more ones from? Now, realistically, the next place you would look if you needed ones would be to look in the tens place. If there were any tens at all in the tens, then I would have 10 ones inside of every 10. But in this case, I don't have any tens here. So when I went next door, I couldn't get a 10 over there to get more ones. So I'm actually going to have to go to my next door neighbor. Now, here's the deal. When I'm in my hundreds, I can shift 100 over to my tens. I can't just shift a 10 over because now this is no longer 100, it's 90. So I need to shift 100 over to my tens, and now I still have 100, but I have 10 tens. And I still have 2,103. And you want to make sure students understand that just because I shifted that 100 over to make 10 tens, I did not change the value of that number. So let's kind of try to match what I just did before I move any more blocks. Every time I make a move with my blocks, I want to change my numbers to match. So I needed more ones. I couldn't get any more ones from the tens column, so I needed to go over here to the hundreds. And I needed to shift one of those hundreds, which didn't leave me with any. One less 100 would be 0 hundreds, and then that gave me 10 tens. 10 tens is the same as that 100. That still doesn't help me with my ones, so I'm going to have to now do another shift, but I'm going to do those shifts one at a time, okay? I'll also make this match, okay? So when I took this 100, that left me with no hundreds, and then that left me with 10 tens, which is the same as 100, okay? I still need more ones, right? So if I take one of these tens and I shift it over to the ones, I just moved the 10. I haven't taken anything away yet. I just shifted it. I'm grouping my number in a different way. So now instead of having 10 tens, I have one less 10. So instead of having 10 tens, I have 9 tens. And instead of having 3 ones, I have 3 ones and then 10 more ones, which is 13 ones. I'll show you how I did it on the expanded form. So I had 10 tens, which was 100, but I shifted 10 over, right? When I shifted 10 over, 10 less than 100 is 90, and 10 more than 3, since I shifted it, is 13. Now I'm looking in the ones place, and now I can do that. I can take away 5 ones from my ones. Now, if you're at home and you don't have base 10 blocks, you can totally draw a picture model of the blocks, and I'll even just do that right now. That's how we do a quick 10 and 3 ones. Then I'm going to take off 8. Not 8. I'm taking off 5. So I'm going to take off 5, 3, and then taking 2 off of the 10. That's going to leave me with 8 ones. Okay? So I have 8 in the ones place, and I have 8 in the ones place here. So now that the ones place is done, my next job is to try to figure out the tens place, okay? So in the tens place, I have 9 tens minus 7 tens, or if I'm doing expanded form, it's 90 minus 70. Can I do that? Yes, 70 is less than 90. So I'm just going to show you how this could work with the picture too. So 90 would be 1, 2, 3, 4, 5, 6, 7, 8, 9 tens. And if I take away 7 of those tens, or 70, that leaves me with 2 tens, or 20. 9 tens minus 7 tens is 2 tens, or 90 minus 70 is 20. All right, so far so good. Let me go over to, now I'm done with my ones and I'm done with my tens. I'm going up to the hundreds column. In the hundreds, I have 0 hundreds minus 600. That's that negative 600, right? 0 hundreds minus 6 hundreds. I can't take away 6 hundreds if I don't have any hundreds there. So I'm going to have to do some of that ungrouping again. Where can I get more hundreds from? Well, I know that there's hundreds inside of 1,000, but I can't just take part of the 1,000 away. I need to shift one of my thousands over to my hundreds. So when I shift one of my thousands over to my hundreds, I have 1,000 less. So instead of 2,000s, I have 1,000. And that 1,000 is still there, but now it's in the hundreds as 10 hundreds, because 10 hundreds is the same as 1,000. If I'm doing it in the expanded form, as I'm shifting that 1,000, 1,000 less than 2,000 is 1,000, and 1,000 more than 0 is 1,000. So now in my hundredths place, I can actually subtract that. If I was drawing a picture of it, I can take away the blocks, but I want to show you guys in case your students want to practice with their model drawing. It would be 10 hundreds make 1,000. 6, 7, 8, 9, 10. And I want to take away 6 of those hundreds. 1, 2, 3, 4, 5, 6. That would leave me with 4 hundreds. So 10 hundreds minus 6 hundreds is 4 hundreds. Or 10 hundreds or 1,000 minus 600 would be 400. So now my hundreds are done. And I can finally do my thousands. If I have 1,000 left, see with my blocks I have 1,000 left, and I need to take away that 1,000. I can even show that with my picture. If I draw 1,000, students, we do 2 boxes, connect the lines. So I had 1,000 and I took that 1,000 away. That leaves me with no thousands. So I don't really have to put anything there because 1 minus 1 is 0 and 1,000 minus 1,000 is 0. So as you can see with both the traditional algorithm and the expanded traditional algorithm, the difference between these two numbers is 428, whether it's in standard form with the digits or expanded form with those values. 428, if I put those together, is 428. So as you can see, this regrouping is tough. That's why I wanted to give you a few different strategies. Any of the strategies will require good understanding of place value, flexible composing and decomposing of numbers using the place value system, because students need to understand why as I'm shifting one group, it gives me 10 of the smaller place value. And if your students are really struggling with that, they probably need to go back to some of that grouping and ungrouping with base 10 materials. So I know that was a long one, but this is a big standard, and I'm trying to make videos for parents and students of the stuff that our students need a lot of practice with in school until they feel confident. All right, happy practicing.